Here comes the second part of the problem. A proton, deuterium nucleus and alpha particle enter into a magnetic field with the same kinetic energy. Find the ratio of their radii. So here we know kinetic energy. Then the formula for radius kr is equal to root over 2m into kinetic energy by b into q. Here all the charged particles are having the same kinetic energy. You leave it and okay, let's go with the same procedure. Radius of the proton, as discussed in the previous problem, mass of the proton mp means electron is e, charge is e. Deuterium nucleus, charge is same as proton but mass is 2 times that of proton. Alpha particle, charge is twice that of proton and mass is 4 times that of it. So it is root over 2 into mass of the proton into kinetic energy of the proton by b into charge of the proton. Radius of the deuteron is root over 2 into mass of the deuteron, kinetic energy of the deuteron, b into charge of the deuteron. Here they all have the same kinetic energy, so I am using the same k here for proton as well as deuteron. And radius of the alpha particle is root over 2 into mass of the alpha particle, kinetic energy of the alpha particle by b into charge of the alpha particle. So the ratio is radius of the proton is to radius of the deuteron is to radius of the alpha particle. And here leave the common things and write the rest. So when you write all this, 2b, k, all these things will be cancelled. 2b, k will be cancelled. So we'll be writing root of mass of the proton by charge of the proton is to root of mass of the deuteron by charge of the deuteron is to root of mass of the alpha particle by charge of the alpha particle. So here mass of the proton mp, so root over mp divided by charge of the proton is e. Here mass of the deuteron is 2 times mass of the proton by charge of the deuteron is still e. And here mass of the alpha particle is, it is 4 times, so it is 4 times mass of the proton divided by charge of the alpha particle is 2 times e. Now cancel the common things. E will be cancelled. MP will be cancelled. So what you are left with right now, it is root over 1 by e. We still write it as 1 is to root 2 by 1 is to root 4 is 2 by 2. So then here comes the ratio for us. 1 is to root 2 is to 1. If they ask what is the ratio of the proton and deuterium nucleus when they have the same kinetic energy, means 1 is to root 2. So deuterium nucleus and alpha particle is root 2 is to 1. So deuterium nucleus, all proton and alpha particle is 1 is to 1. So like that we can find out. So in the next part, what if proton, deuterium nucleus and an alpha particle enters into a magnetic field with the same potential difference across which they are accelerated? Then find the ratio of the radii. That we'll see in the next part.